Hi, I'm Jamie, and today I'm going to explain how to do the second free response question on the 2013 AP Calculus AB exam. So this is a fairly typical particle motion question. It's pretty standard to what you see on the test. The only thing it doesn't cover is displacement calculation, but really you just have to understand how the relationship between velocity, speed, displacement, distance, acceleration, those sorts of things, those motion functions. So the question reads like this. A particle moves in a straight line. For 0 is less than or equal to t is less than or equal to 5, the velocity of the particle is given by v of t equals -2 plus t squared plus 3t to the 6/5 unparenthesis minus t cubed. And the position of the particle is given by s of t. It is known that s of 0 equals 10. So we have our velocity function here, and we're told that there is a position function. We don't know what the position function is, but we know that position is always the derivative of velocity. We also have an initial condition on our position. Very important to notice this. If you don't notice this, you will screw up all of the other answers to the problem. S of 0 equals 10. You have to remember that. So part A, find all values of t in the interval 2 is less than t is less than 4, for which the speed of the particle is 2. So, okay, so take note, speed, not velocity, speed. So speed is absolute value of v of t equals 2. So how do we find out that? Well, we're certainly not going to calculate it by hand. I mean, look at this crazy function. This is a calculator allowed one, so we have to use a calculator. I'm going to show you how to do it using the computer emulation software for the Nspire CAS. So we're here in our calculator, and so first thing we need to do is define a function for v of t, because we don't want to have to type in that giant screed of a function multiple times. There we go. Now we have our v of t. So now we need to now we need to graph v of t. So we will insert a new page for graphing. There we go. Now we see our v of t right there. Except it's v of x because it's f of x here. You need to use the same variable in both. So now we need to find where the absolute value of v of t equals 2. So let's change that v of t. We will put an absolute value around it. There we go. So we need to set where this equals 2. So we need to graph y equals 2 and find the intersections between 2 and 4. Lower bound 2, upper bound 4. And that found the first intersection. Let us zoom in. You have to be a little careful with this. There's 2 intersections right there. 3.13. Now we need to find the second one. So if we just do the same thing we did, it'll only find the first intersection. What we need to do is put our lower bound there, and then we can type a 4 for our upper bound. There, now it found 3.47. So our okay, so because it's the calculus exam, we need more decimal places. So if we zoom in, there, now it's out of the way. And if we hover over this and then press plus, that will insert more decimal places. There we go, 3.4734. So rounding up, our answers are... You might think you need to show a little more work in this, but actually this amount of work is fine. Because it's a calculator question, you don't need to show any sort of in-depth calculation. Okay, so on to part 2. So now we need to find the position s of t. Now position is always a derivative of velocity. So, and by the fundamental theorem of calculus, we can write this is the fundamental theorem of calculus. It gives us this function. However, we also have to remember that this has a constant c attached. So what is the value of that constant? Well, we know that s of 0 equals 10. So if we write we know that c must equal 10. So that's our expression there. Now we need to find the position of the particle at t equals 5. So what does s of 5 equal? Well, for that, we have to go back to the calculator. Okay, so we need to find s of 5. So that equals the definite integral from 0 to 5 of v of s ds plus 10. And control equals, for approximate, negative 9.207. Okay, so we can erase the question mark and write in negative 9.207. Okay, so for part C, we need to find all times t in the interval 0 less than t is less than 5, at which the particle changes direction, and we need to justify our answer. Okay, so that's kind of a red alert thing, justify your answer. We need to prove it. We can't just find a number. So find places where it changes direction. That just means where the velocity changes sign, or goes from going forwards to going backwards, backwards to forwards. So, to find those places, we need to go to the calculator. So if we go back to our graphing thing, we need to find places where the velocity changes sign. So that means we can get rid of all the stuff we have here. Now we just need v of x. Get rid of the absolute value business. Okay, so here we are. So we can see there's 2 zeros. Is that one below 5? It's hard to tell. Let's find out. Okay, we found one. Now let's check that other one. Okay, so that one is under 5. So it is at 3.32 and 0. Let's zoom in to there. Okay, so we have 0.536 and 3.318. Okay, so now we need to write our justification statement. So, okay, there we go. V of t goes from negative to positive at t equals 0.536, and v of t goes from positive to negative at t equals 3.318. Particle changes direction at t equals 0.536 and 3.318. Now, you might think you could write v of t switches sign at these 2 points, but that was kind of a gray area. On the AP test answers, it suggests that you write 2 separate ones. So, to be on the safe side, you should probably do that on the test. So, part D. Is the speed of the particle increasing or decreasing at t equals 4? Give a reason for your answer. Okay, so is the speed of the particle increasing? So in other words, is it going faster and faster as it goes along, or is it going slower and slower? But again, we have to be careful because speed and velocity are not the same thing. So it could be going faster and faster in the negative direction, or faster and faster in the positive direction. Okay, so we need to see exactly what the graph is doing at t equals 4. And okay, so we can see the graph is negative, and we can see visually the derivative is negative. So it's definitely speeding up, because it's going faster and faster in the negative direction. However, to meet the AP standard, we need a little bit more proof. So let's figure out, first of all, we need to find those values to 3 decimal places. So for that, we will just do v of 4. Control, enter. So negative 11.48. And if you go up there, okay, so we can see that's negative 11.747, blah, blah, blah. Okay, so now we also need to find the derivative at a point. So for that, we will go over here, d over dt, v of t, and then we need to type in, we need to tell it what point. So for that, we will use control equals sign, go over to this bar, and then t equals 4. That tells it we want to find the derivative at the point t equals 4. Control enter, and okay, negative 22.3. Alright, so okay, so now we have these values. Now, because it says give a reason for your answer, we just have to write a quick justification. In this case, because the particle's velocity and acceleration are negative, its speed is increasing. that's pretty much all you have to write for the AP test justification. So as you can see, this problem is not that bad. It's more about plugging your knowing how velocity, speed, or acceleration, and position relate, and plugging those values, and how to use your calculator to find these values when the function is a little bit too nutso to calculate by hand. If you need more practice with these functions, there's a great lesson on Khan Academy. I put a link in the description for you.